Solving exponential equations of the form a times e to the x plus c times e to the negative x is equal to b. We start off our demonstration here with solving the equation e to the x plus e to the negative x equals 2. So first thing we're going to do is we're going to use that negative exponent rule, changing e to the negative x to 1 over e to the x. And then I'm going to multiply both sides by e to the x. This will get rid of the fraction. So I have e to the x times the quantity, e to the x plus 1 over e to the x is equal to e to the x times 2. Continuing with our solving procedure, we're going to multiply that e to the x on the left side. Using the distributive property in the exponent rule, we get e to the 2x plus 1. And on the right-hand side, we have 2e to the x. We subtract the 2e to the x over, effectively setting the equation equal to 0. And then I'm going to make a substitution. I'm going to let the u variable equal e to the x. And what this does is it allows us to see a quadratic equation kind of hidden behind this exponential. Now that I have a quadratic, I may use quadratic formula, or I may use a factoring procedure to solve this in terms of the u variable. And from our quadratic form, u squared minus 2u plus 1 equals 0, we can factor this into u minus 1 times u minus 1. So my solution in terms of u would be u equals 1. But now we're going to undo that substitution and get e to the x equals 1. And then we're going to undo that exponential with logarithms, effectively having x is equal to the natural log of 1, which of course evaluates to 0. Now that we have seen an example, let's examine the general form. A e to the x plus c e to the negative x equals b. We're going to use similar steps as done in our previous example, and we're going to solve this equation. So again, we use the negative exponent rule to start with, changing that e to the negative x over equal to 1 over e to the x. So we have a e to the x plus c divided by e to the x equals b. Then I'm going to multiply both sides by e to the x. This will get rid of this fraction. So I have e to the x times the quantity, a e to the x plus c divided by e to the x. And that's going to be equal to e to the x times b. Continuing with our solving procedure, we're going to distribute that e to the x over, and we're going to use the exponent rule for multiplying the same bases. We add the exponents. Using these rules properly, we get a times e to the 2x plus c is equal to b times e to the x. I'm going to use the subtraction property. I'm going to move that b e to the x over, effectively setting the equation equal to 0. And we have a times e to the 2x minus b e to the x plus c equals 0. Now, if I make a substitution that u is equal to e to the x, then I have a quadratic form hidden in this exponential equation. So under this substitution, I can now have a u squared minus bu plus c equals 0. And again, now that I've exposed this quadratic form, I can use either quadratic formula or a factoring procedure to solve in terms of the u variable. Since we don't know the values of a, b, and c directly, we're going to just use the quadratic formula. So we have the opposite of the coefficient of u, which is negative b in this case, plus or minus the square root of that coefficient of u squared, again that's negative b, minus 4ac, and that whole quantity is divided by 2a. After a little simplifying, we undo the substitution. Remember that u was equal to e to the x. So now we have e to the x is equal to b plus or minus the square root, b squared minus 4ac, divided by 2a. And of course, now we can undo the exponential with logarithms, and we end up with x equal to the natural log of that formula, b plus or minus square root b squared minus 4ac, all of that divided by 2a. Because this is a general formula, we have to make sure that the domain restrictions are adhered to. So b squared minus 4ac has to be positive. That's the discriminant. The discriminant has to be positive in order for the solutions to be real. And either b plus the square root of b squared minus 4ac, all of that divided by 2a, or b minus the square root of b squared minus 4ac, all of that divided by 2a, must be a positive value for the logarithm to exist as a real quantity. Therefore, checking the answers are going to be required. Let's test our new formula on the following problem. 2e to the x minus 3e to the negative x equals 1. Now in this equation, a is 2, c is negative 3, and b is 1. And our formula suggests that x is going to be equal to the natural log of 1 plus square root 13 over 4, or possibly the natural log of 1 minus the square root of 13 over 4. But the square root of 13 is between 3 and 4. And that means that 1 minus that is a negative value. And the natural log of a negative value doesn't exist as a real number. So the only candidate we have is going to be the natural log of 1 plus square root 13 over 4. If you put this value in to the equation, you will see that this value checks. Now let's solve the same equation using the procedure that we developed in the first example, as well as in the derivation of our formula. So we have our given equation, 2e to the x minus 3 times e to the negative x, and that's equal to 1. So again, we use the negative exponent rule, changing that negative exponent to a positive one. 2e to the x minus 3 divided by e to the x equals 1. Then again, we multiply both sides of the equation by e to the x. This will get rid of the fraction. And when I do this, I get 2e to the 2x minus 3 is equal to e to the x. Move that e to the x over to the other side of the equation, setting it equal to 0. Doing our substitution, u equal to e to the x. And then we have our quadratic form. 2 times u squared minus u minus 3 is equal to 0. Because we have a u squared equation, we may use quadratic formula or factoring to solve. We'll use the quadratic formula here. And we see that we have 1 plus or minus the square root of 13 over 4 as the u solutions. But remember, those solutions have to be positive values. And 1 plus the square root of 13 over 4, that's definitely positive. But 1 minus the square root of 13 over 4, that's a negative value. So u can only be 1 plus square root 13 over 4. And when I make the change back to the original variable, u was e to the x, we have e to the x is equal to 1 plus square root 13 over 4. And when I convert to logarithmic form, either by taking the logarithm of both sides or using the definition of logarithm, either method results in the same thing. We have x is equal to the natural log of 1 plus root 13 over 4. And we see that we have the same solution. Thank you for your time and attention.